Hello and welcome to another daily coding problem. Today's problem comes from dailycodingproblem.com. No surprise there, right? Every day they send an email. It has a question that was asked in an interview at some tech company. Today's question comes from Google. And as usual, I'm just going to give myself an hour, start my stopwatch. And if I'm not done in an hour, then I'm just going to stop. Probably have to Google some stuff, figure out how to solve the question, maybe learn something. But hopefully I'll finish within an hour. And then tomorrow I'll do a different question. So let's take a look at what we got going on for today. Daily code problem, I think, is the website, something like that. I don't know who runs it, but they send a nice question every day. So as I said before, this comes from Google. Let's read the question together. A unival tree, which stands for universal value, is a tree where all the nodes under it have the same value. Given the root to a binary tree, count the number of unival subtrees. For example, the following tree has 5 unival subtrees. Alrighty. 5 unival subtrees. So unival is where everything under the parent node has the same value. So this is not a unival tree because it has a 1 and 0 under it a bunch of times. This would be because everything under it is nil. So this is 1. This would be 2. This would be 3. This node would be 4. And this node would be 5. So every leaf in this tree is a unival tree. And we have 4 leaves, and then we have 1 tree that actually has nodes under it that are the same value. Okay. So let's use this tree as our test case. And per usual, I'm going to write the test first. That way I don't actually have to think about how to write this code. I'm just going to write the test and we'll go from there. So first, let's create a solution test. And we'll use Minitest for this as usual. Minitest auto run. And Minitest pride so that we get color. And then we also need to require our solution, which is what we'll be testing. So let's describe what the solution looks like. This is going to be that test case they gave us. And we'll call this count univals. Pretty sure that's what they called it, right? Unival. Unival. Okay, yeah. What a weird name. It returns the number of unival trees. Right? And I'm going to paste our example in here now that they gave us. That's going to be this tree. Let's paste it. Let's put a comment. Let's move it over a little bit. Right about there. That looks good. Let's put some comments in front of it. Okay. So now we got to create this tree in code. And Ruby doesn't give us a tree class, but we can make that. It'll be pretty basic. So let's build out this tree now. We'll assume we have a thing called tree node. And this is going to be the root. In fact, I'll just save it as the root. And the value of our top node there is a 0, right? And then it's got a left subtree that is going to be a new tree node with a value of 1. And that's it. And then we've got a right subtree which is going to be a new tree node with a value of 0, right? If you're following along, I'm on this node right here now. And this is going to have a right subtree with a value of 0 as well. And it's going to have a left subtree with a value of 1. And that node, we're on this node now, we're on this one here, and that's going to have 2 nodes under it as well. So then we have a left, which has a value of 1, and that's it. And then we have a right, which has a value of 1 as well, and that's it. And I think that is our whole tree. So let's count our nodes to make sure we got them all. 1, 2, 3, 4, 5, 6, 7. And then we have 1, 2, 3, 4, 5, 6, 7. Excellent. We have 3 zeros. Yep, I see 3 zeros and 4 ones. Perfect. Okay, so now we've built our tree in code. Let's write our test. We want to assert that we get 5 back when we count the univals for our root. And my washing machine is making a lot of noise right now, so I will be right back to turn that off. 1 second. Okay, sorry about that. So our test, here we have assert equal 5 for our tree. This looks good to me. Let's get rid of some white space and let's run our test and see what it tells us to do. First error we got there, it's telling us we don't have our solution. So let's create it. Excellent. Next failure. We don't have a tree node. We were expecting this, right? This should be pretty basic. A tree node is going to have a few things. It's going to have a value and a left and a right. And we'll set those in the initializer. Values required. Left is optional. Right is optional. Oops, oops, oops. There we go. Okay, now we got our class. Let's run our test again. There is no method called count univols. This takes a node. And we got our first failure. Expected 5. Actual is nil. Perfect. So let's return 5. Sweet, we did it. We're done. No, I'm just kidding. All right, now we actually have to write some code. This is the tough part, right? Okay, so with trees, pretty much what I do all the time, what I'm learning to do. Now, see, I'm new to these types of problems, right? That's why I'm doing these every day so I can get better at them. But what I've learned so far with trees, most of these tree problems you can solve with recursion. And the nice thing about recursion is you don't necessarily need to understand even what it's doing, although that does help. You just assume that it's going to do the right thing and then come up with a base case or a couple base cases. And then everything just seems to work. And 90% of the time that works. And then you can move on with your life and the problem is done with. So let's do that. So let's think about some base cases here. Okay, the first thing that comes to mind is if the node that we've passed in is nil, right? If we pass in a tree that's got nothing in it, not even one node, then we'll just return 0. Unless node. So if we pass in nil, we pass in no tree at all, then I guess it would make sense to return 0, right? There's nothing to count there. Otherwise, we need to actually do some counting. So the way, so what does that mean? How can we write that? So this tree is going to be, okay, let me take another step back here. What would be another way to think about this? I think I can think about this without actually having to think about how it works, right? So count univals. So the univals for this node would be all, how about, okay, so how about we assume we have a method that returns true if the tree that we pass in is a unival, right? So if this tree starting at this node is a unival, then we'll return 1. Otherwise, we return 0, right? And then we can add that to all the univals on the left side of the tree, right? Yeah, let's do that. Plus all the univals on the right side of the tree. So to write this another way, 1, 0. Oops. That looks good. Okay. Let's see if this makes sense. So if we pass in nil, then hey, no univals. We have no nodes here. Otherwise, if this tree starting at this node is a unival, then we have 1. We have a tree that is a unival, and then we'll add to that all the intervals that go down the left side and all the intervals that go down the right side, right? Yes, that makes sense. So now we just have to write this. We have to write a method that returns true if the root node that we pass in is a universal univalue. What do they call it? What does unival stand for? Universal value tree. Okay. So let's write this magical unival method now. Okay. Let's think of a base case here, because I think we're going to want to use recursion in this method as well. So if our node is empty, then we can return true. If we have a node but both of the subtrees are empty, so if node.left is nil and node.right is nil, then we can also return true. right? Or to rewrite without using the dot nil here, return true unless node dot left or node dot right. So if we don't have a node, then sure, it's a unival. If we have a node, but we don't have a left or right, then sure, it's also a unival, because now we know we're at a leaf, right? And, okay, so I think that's a good start. And now, we know we have a node that has something, some subtree, right? So we just need to take the value of the current node Yeah, so we need to take the value of the current node, the left node, and the right node. So let's grab those. And I'm going to put these in an array here. So we have node.value. And then we have node.left.value, but this could be nil, right? And then we have the same for the right. So now we've got potentially 3 different values here, or potentially all the same value, right? So let's compact it to remove any of the nils, and unique. Now we would expect values to only have one number in it if they're all the same, right? Otherwise it'll have multiple numbers. So if values.count, actually we don't need an if here. Values.count equals 1. So this value, the value of this node and the value of both nodes under it are the same. And the left subtree and the right subtree are also unival. Right? So unival. So if all of our values are the same for our current node and both nodes under it, and the entire left subtree is the same and the entire right subtree is the same, then we can also return true. I think we've written all our methods now, so we can run it and see if we've got any kind of weird syntax errors or if we made a mistake, huh? Let's give it a shot. And it worked. Man, that feels so good. It feels so good when you write all this freaking code and then the test pass. That's so cool. So this makes sense to me. And it's almost magic that it works, right? So let's clean this up. Having 2 return statements at the top seems a little weird, but maybe not. Let's see what happens if we put this all in one line. So return true unless node and, wait, node, is it node and? Let's see. Node and, yeah, it's going to be an and. Yeah. Node and node.left or. So return true unless we have a node and the left or the right also exists. Let's run it again. Okay. Okay, that looks good. This looks good. This looks good to me. Return 0 unless node. And just to prove that this is right, that we're not making stuff up. Okay, good. That failed. Okay. Yeah. Sweet. This looks good to me. Let's see if we can add another test case in here. And I guess the crappiest part about this is having to type all this stuff again, right? But, you know, that's sometimes you just got to do that. That's what a test is, huh? So let's make our tree a little bit different. I'm just going to change some values here. We'll keep a similar structure, but maybe I'll just change some of the values to limit our typing a little bit. Well, actually, we'll change the structure a little bit. How about that? So let's add one more 0 to the end of this tree for starters. So that's going to be this one. All right. And then let's change. So that should give us one more subtree, right? Because now this is a subtree and this is a unival subtree. And actually, if we know that, right? Let's try increasing this count here to 6 before we make another change. And let me also count these again just to make sure. So we got 1, 2, 3, 4, 5, 6, right? Let's run it. Excellent, that passes. So now let's complicate this a little bit more. I'll change this to a 0. And I would expect now for it to be 5 again. No. Oh, if only changing my picture changed the code, right? Gosh dang it. Okay, let's see. Now we gotta find this. Here it was. Left. This changed to a 0. Okay, excellent. Okay. You know, I'm confident that this is working now. We've made enough changes to this. We've ran a couple different scenarios. I think the code's good. I'm happy with this. So let's go ahead and before I commit this, I'm gonna make this test a little different. So now this brings it down to 3. No, 4. I think we just removed 1 just now. Oh, again, I gotta remember to change the actual code. Okay, so 0, 0, and then this is a 1. Okay, perfect. Cool. Wow, that was fantastic. Okay, so that took us about 22 minutes or so. I think that's a good place to wrap up. Let's throw this into a commit. Recursion is so cool sometimes. That looks good. That's our test. Okay. Add solution to today's problem. And today is the 9th. Go ahead and push it on up to the GitHubs. And I'll have a link for this, of course, in the description as well, if you wanted to check this out. Cool. Well, that's it. That's all for today. Let me adjust this. Mic that keeps spinning. Okay, maybe I'll talk over here. Well, thanks for joining me. I'm going to try to do another one of these tomorrow, and the day after that, and the day after that, and as many as I can keep going. Some people are starting to watch now, so that's getting kind of exciting, but if it kind of dwindles off, I'll just start watching these videos on my own, I guess, and stop uploading. Anyways, thanks a lot for checking it out. I'll see you tomorrow, and yeah, dailycodingproblem.com. Bye.